Now let's see insertion at end. Let's consider doubly linked list with 4 nodes. The blue node is a new node to be added and we have to insert them at the end. Now the last node's next pointer points to the previous of the new node and the new node's next points to the null. Finally, after insertion, it becomes like this. The new node is added at the end and end node remains as the end. The newly added node now becomes the tail of the linked list where the next pointer points to null. The time complexity of insertion at the end is O of n since we have to traverse the whole list, and the space is O of 1 which is of constant space. Now let's see about deleting a node from the beginning of the doubly linked list. Deletion at beginning. In order to delete a node at head, we have to follow the algorithmic steps, which are copy the head node in temporary node, make the second node as head node, the previous pointer of the head node is made to point to null, and the temporary node is deleted. The first step is we have to copy the head node to a temporary node. Second step is to make the second node as head node. The third step is the previous pointer of the head points to null. And the temp node is automatically deleted by the garbage collector. In this way, deletion at beginning is carried out. The time complexity is O of 1 since its deletion is at the beginning and the space is of O of 1. Now let's see how to delete a node from the end of the doubly linked list. Now, in order to delete a node at the end, we have to follow the same steps but with a slight change. These are the algorithmic steps that are involved to delete a node at the end. The first step is we have to copy the head node to a temporary node as before we have seen. Now we have to make the second node as temp2 node. Then we have to traverse until temp1 of next is null and make temp1 of period as temp2. Then the temp node is automatically deleted by the garbage collector, and then we have to point the temp2 node's next pointer to null. The time complexity is O of n since we have to traverse the list to the end, and the space complexity is O of 1 which is of constant space.